LaHouse Resource Center is a showcase of solutions for producing high-performance homes for our hot, humid climate and natural hazards, all based on results of building science research. It demonstrates a range of proven ways to gain so many benefits to enjoy every day and to have more control over our lives. Think about it. As we shape our homes, we shape our future.
One of the 4 high-performance building systems demonstrated in the construction of LaHouse is an enhanced 2x4 wood framing used to build the midsection of LaHouse that is detailed for benefits beyond building code minimum standards. This building system uses 2x4 wall studs spaced 16 inches apart, but is enhanced with stronger, straighter engineered wood products, with fortified features to meet the design loads of a high-wind hurricane zone, with borate-treated wood for lasting protection against both decay and the destructive Formosan subterranean termite, known to cause major structural damage in only 1 year, and specially detailed for greater energy efficiency and moisture control for our hot, humid, and rainy climate. In part 2 of this video, you'll see how the enhanced 2x4 framing in LaHouse was assembled from start to finish and why. Enhanced 2x4 framing part 2, from the ground up. A sill gasket was installed along the edge of the slab under the bottom plate with dual purposes. It seals the gap under the bottom plate to stop a major source of air leakage, and it stops moisture that wicks up concrete from wetting the wood. This is known as a capillary break. Anchor bolts that were set in wet cement every 16 inches between the studs are secured with 3-inch washers for high wind resistance. Borate-impregnated laminated strand lumber, commonly called LSL studs, made from local, fast-growing trees, are used instead of imported lumber. LSLs are stronger, straighter, and greatly reduce waste that commonly occurs from warpage on site as well in the production of the 2x4 lumber. Ceiling joists are engineered wood I-beams that can span wide spaces with straight, strong support for squeak-free floors above them. Like LSLs, they efficiently use local forest products and allowed us to avoid using 2x12 lumber from old-growth trees. The roof is framed with 2x8 borate pressure-treated rafters to support the weight of the tile roof. Since the roof extends over the porches, it is supported and connected to both porch columns and attic knee walls. LaHouse uses metal hurricane hardware to connect all of the components of the framing to create what's called a continuous load path from the foundation to the roof. In addition to the anchor bolts, the walls have plate-to-stud connectors on every stud to resist uplift forces, metal straps to tie window and door headers to framing and top plates, twist straps that wrap over roof rafters and connect them to the wall framing for greater resistance from the risk of splitting wood failures, and rafter straps at the roof peak to hold the 2 sides of the roof framing together. Borate-treated plywood wall and roof sheathing panels offer high strength and moisture performance as well as decay and termite resistance. The fortified walls are fully sheathed with 15 30-seconds thick plywood and a specified nailing pattern to resist racking, leaning forces. All edges are nailed to framing. The fortified roof decking is 19 30-seconds thick and attached with special ring shank nails at 6-inch spacing to resist pullout from uplift. Notice the decking is also marked with a grid to make installation faster and more precise. To reach the higher energy efficiency standards of LaHouse, the 2x4 framed walls were enhanced. Wall cavities are filled with sprayed cellulose insulation made from recycled newspaper with a stabilizing adhesive and a borate fire retardant, providing R13 insulating value between the studs. Sprayed insulations that fill every nook and cranny without void or compression provide about 30% better performance than typical methods. Spray foam was used on the band joist between the first and second levels to both insulate and air seal. In addition, the walls are lined with exterior rigid foam insulation panels to increase insulation value to R19 and to provide a layer of continuous insulation without the stud gaps. The front wall has a water-managed exterior insulating finish system, a synthetic stucco that allows drainage of any water that gets in. The back wall has foil-faced iso foam board with taped seams to provide insulation, radiant barrier, weather barrier, and air barrier all in one. And last but not least, windows and doors are the biggest insulation gaps in a wall. LaHouse has 10 types of insulated doors and windows that meet ENERGY STAR label criteria for the Deep South Climate Zone 2. The front door is a fiberglass skin insulated door stained to look like a beautiful wood door, only much better. The windows and back door have clear low-E glass with a very low solar heat gain coefficient to greatly reduce summer heat gain. The front porch windows are wood frame with metal cladding for low maintenance. Hurricane protection is provided by removable impact-rated fabric screens that attach to anchors in the porch archways. The back porch windows have durable composite framing from recycled material and are protected with lightweight, translucent storm panels that are easy to install on pop-open tracks. The attic in this section of LaHouse is a specially detailed unvented attic with R30 open cell spray foam under the roof decking with a fire retardant coating. Plus, knee walls are insulated to R19 like the outside walls, and no insulation on the attic floor. Why do this? It does cost more than insulating the attic floor, but can offer several benefits. Moving the insulation boundary from the ceiling to the roof line puts the air conditioner and the ductwork within conditioned space, eliminating the typically large energy losses from leaky, poorly insulated ducts in hot attics. This reduces the cooling load, so you save money by buying smaller equipment and by saving energy every day. The room ceiling below does not need to be made airtight, saving labor. And no soffit and roof vents omit the risk of wind-driven water intrusion in storms. With those benefits are important precautions to avoid problems. There should be no fuel-burning equipment in an unvented attic, unless it is the direct vent sealed combustion type. The equipment in LaHouse unvented attic is all electric. A geothermal heat pump that super efficiently heats, cools, and preheats water. There is a supply register to slightly condition the space for humidity control. The roofing underlayment should be impermeable to water vapor to prevent moisture problems. LaHouse used an adhesive membrane underlayment under the tile roofing. A few points to keep in mind. A house is a system. How it's built affects not only the energy usage, but also air quality and moisture conditions. It is possible and practical to have it all, but the details do matter. We'd also like to pass along some lessons we learned while building LaHouse. The construction workers benefit from training in both the methods and their purposes to ensure the desired outcomes. Detailed construction documents and specifications, plus a quality control system, are especially important when methods and materials deviate a little from how it's typically done. Code requirements for unvented attics, knee wall insulation materials, and other innovations can change over time with fire code changes and new knowledge. In summary, conventional 2x4 wood framing can easily be enhanced for greater energy efficiency, comfort, durability, and storm resilience. An understanding of basic building science principles, detailed specifications, and quality controls such as performance testing can help ensure the best results. With strategic trade-offs, up to 30% greater energy efficiency can be achieved with little added cost. Beyond that, upgrades do add cost, but that investment can reap greater returns. You're invited to explore LaHouse inside and out. Its cutaways, feature signage, models, publications, library, and the website, and to learn about how you can shape your future with a high-performance home.